Welcome back. We're going to talk about even versus odd functions again. We saw in the last video that for cosine and secant, if you put the positive and negative of an angle measure in, you got the exact same thing. However, when you did it for sine, cosecant, cotangent, or tangent, if you chose any number or its opposites, your answers were actually opposite, which made those odd. So basically, if you look up here, if you're taking the cosine of a negative angle measurement, you can actually not even think about the negative. You could just do cosine 60 and write it down. Or cosine 45 if it happened to be negative 45. You don't even have to. You could ditch it. So we're going to actually find out about some other functions. If you look here, these two were our ones that we said were even. So you honestly can just drop the negative. One of the rules of simplifying trig expressions is that you're not allowed to have a negative argument or negative angle in here. So if we have one for these two, we can ditch it. For the other four, we can simply pull it out in front. So if you have sine, cosecant, tangent, and cotangent of a negative argument or negative angle, you can just put the negative out in front when you are simplifying it. So let's look at some other functions that have trig in them. So we're going to look at our first example, example 1. We're going to do f of x equals negative 2 cosine x. To be able to find out if this particular one is even or odd, we need to compare this right here to f of negative x, which means I replace all the x's in the original function here with negative x. So f of negative x equals negative 2 cosine negative x, and then simplify. Well, simplify, you are not allowed to have a negative argument, and for cosine we learned that it is not needed. You can just ditch it. So I can rewrite it as negative 2 cosine x. So now that I simplified it, I compare it to the original. They are exactly the same. So I say it is an even function, which means when I graph it, it'll look exactly the same on the right side of the y-axis as it will on the left. Next one, example 2 that I like to do is f of x equals tan x plus sine x. Again, to determine without graphing if it is even or odd, I replace all the x's with negative x. Both of these are ones that I pull the negative out in front of each term. So this becomes negative tan x and negative sine x. Well, since both of them were both positive to start, and now both of them, both terms are both negative, they're complete opposites, I would say that this one is an odd function. Third one I would like to do is one with a fraction. So I'm going to do cosine x, f of x equals cosine x over x. And if I want to see if it's even or odd, I need to find out what happens when the x is the opposite, or we'll say negative for right now. I will replace all the x's with negative x's and simplify. Uh-oh, I have a negative argument. For cosine, I'm allowed to ditch it. So it's cosine x divided by negative x. A positive divided by a negative is simply a negative fraction. So instead of putting it top or bottom, I just put it out in front. Here is the original fraction, which was positive. Now we have a one that's negative, so we say that this one is odd as well. I want to do one with neither. Let me do an example 4 here. Let's do example 4. We'll say f of x equals, let's say, 4 secant x plus 2 sine x. Again, rewrite it, but replace all the x's with negative x. Okay, And uh-oh, I see negative arguments. Well, this one I'm allowed to ditch, and this one I pull in front. So it's 4 secant x, pull it in front of the term. That means right in front of that 2. Minus 2 sine x. Okay, the original one was both positive. This one has a positive and a negative, so they're not both opposites. So for this one, knowing if it's even or odd, it's neither of them. It is nothing. And this concludes the video on even and odd.